We will now look at the second case of improper integrals, which is unbounded integrands. So if f is continuous on the interval from a to b, including b but not a, where the limit as x approaches a from the right of f of x is either positive or negative infinity, then the integral from a to b of f of x dx is equal to the limit as c approaches a from the right of the integral from c to b f of x dx. So this happens when our integrand is actually not defined at a point. So for example, you'll notice that this integrand, if I stick in 0, I get 1 over 0, which is undefined. In addition, the limit as x approaches 0 from the right of 1 over 0 is going to be infinity. So it does fall into our case. So this is the limit as x approaches a from the right, or 0 from the right. Sorry, the limit as a approaches 0 from the right of a to 8 of 1 over the cube root of x dx. So this is the limit as a approaches 0 from the right of, well, this is x to the negative 1/3, so I'll add 1 and then divide by that number. And we'll go between a and 8. So I now have the limit as a approaches 0 from the right, 3 over 2 times 8 to the 2/3 power, minus 3 over 2 times a to the 2/3 power. So 8 to the 2/3 power is 4, times 3 over 2 is 6. And as a approaches 0 from the right, this thing becomes 0. So my answer here is 6. So since this is not defined at 1, we'll look at the limit as a approaches 1 from the right of the integral from a to 2 of 1 over the square root of x minus 1 dx. And in order to evaluate this, I'm going to let u be equal to x minus 1, so that du is equal to dx. So now this is the limit as x approaches, or as a approaches, and we'll notice if x is 1, u is going to be 0, so 0 from the right. The integral from a to is x is 2, u is 1, of 1 over the square root of u du. So this is the limit as a approaches 0 from the right of, we add 1 to the exponent and then divide by that number, between a and 1. So the limit is a approaches 0 from the right of 2 times 1 to the 1/2 minus 2 times a to the 1/2. So this will be 2 minus 0, which is 2. We can also do this if the limit at the top is undefined. And in this case, we need the limit as x approaches b from the left to be negative infinity or positive infinity. So for example, we know that tangent of pi over 2 is undefined. So this will be the limit as b approaches pi over 2 from the left of the integral from 0 to b of tangent theta d theta. So this is the limit as b approaches pi over 2 from the left of the integral of tangent is ln of secant theta going between 0 and b. So we have the limit as b approaches pi over 2 from the left of ln of secant b minus ln of secant of 0. So secant of 0 is 1, and ln of 1 is 0. So as b goes to pi over 2 from the left, secant of b is going to get closer and closer to infinity. And ln of something getting bigger and bigger, going to infinity, is also going to be infinity. So this integral is infinite. We'll do one last one. And in this case, we'll do a substitution first. I'm going to let u be equal to x to the 4th minus 1. So du is 4x cubed dx. Or 1 over 4 du is equal to x cubed dx. So this new bound is going to be negative 1 on the bottom. On the top, we'll have a new bound of 0. And this is going to be 1 over 4 times the integral of 1 over u du. And we know that 1 over 0 is undefined. So I have the limit as b approaches 0 from the left of 1 over 4 times the integral from negative 1 to 0 of 1 over u du. So this is the limit as b approaches 0 from the left of 1 over 4 ln of the absolute value of u going between negative 1 and b. So we have the limit as b goes to 0 from the left of 1 over 4 ln of b minus 1 over 4 ln of the absolute value of negative 1. So as b approaches 0 from the left, ln of the absolute value of that is going to be approaching negative infinity. So we have negative 1 over 4 times infinity minus 0. So in this case, this will go to negative infinity.